Hi folks, welcome back to the 9.1 Infinite Sequences and Summation Notation video. So in this section, we're going to finish up with one more example on how to use this recursive formula, and then we're going to talk about summation notation. So let's take a look at example 3. Example 3 says find the next 3 terms for the given recursive formula. Now, I wanted to do this example because it looks a little bit different than the other one, but it's actually very similar, okay? So we've got a starting term, we've got our a sub 1, but they also give us a second starting term, or the second term in the sequence, a sub 2. Now, sometimes you need to be given 2 values in order to find the third. That's just sort of how the pattern is, okay? And so in this case, I notice that the pattern tells me that if I want to find one term, I need to know the one that came before and then the one that came 2 before. All right, so let's go ahead and write out our a sub 1, a sub 2, and then use that formula in the pink to find our a sub 3, okay? So we've got a sub 1 equals 4. That's my first term. A sub 2 is 7. That's my second term. So now to find a sub 3, okay, that means I'm going to do 3 times a sub 2, because 2 is 1 less than 3, minus 2 a sub 1. All right? So if I look at the patterns here in the subscripts, I have n, which is 1, this will be 2, and this will be 3, okay? So to find the third term, I need to know the first term and the second term. So let's plug in our numbers. 3 times 7 minus 2 times 4 gives me 21 minus 8, which is going to be 13, okay? So I have the first term, the second term. Here's the third term. Now I need to find the fourth term and the fifth term so that I have the next 3 terms, okay? So a sub 4 is going to be 3 a sub 3 minus 2 a sub 2. Let's plug in the numbers we know. 3 times 13 minus 2 times 7. So 3 times 13 is going to give me 39 minus 14. That will give me 25 as my a sub 4. All right, we have one more term to find here. A sub 5 equals 3 a sub 4 minus 2 a sub 3. So I get 3 times 25 minus 2 times 13. That gives me 75 minus 26, and that gives me 49. Okay, so my sequence looks like it starts with 4, 7, 13, 25, 49, and because it's an infinite sequence, a ... to show that you know that there are more terms, these are just the first 5 terms. Okay? All right, so let's move on to summation notation. So, summation notation uses the Greek letter sigma, okay? So this part right in here, that is our sigma. And sometimes you hear summation notation also called sigma notation. All right, so sigma notation and summation notation are the same thing. Now, the textbooks tend to write pretty fancy summation notations. You can write it sort of like a pointy E, so I write it like 1, 2, 3, 4. Okay, so I don't have like this part and this part in mind. Some people like to write it more like the textbook, and so they have the little lines there. But it's really a personal preference, okay? But what does this symbol mean? This symbol means that you're going to add terms together. And so this number at the bottom, k equals 1, tells you where to start adding. And this number at the top, m, tells you where to stop adding. Okay? And so we can see this that because we start at k equals 1, we're going to start with a sub 1. And because we want to finish at k equals m, we're going to stop at a sub m. Okay? Now, just to kind of plant a seed, if I have my summation notation and I have a number up here, okay, that means that this is going to be called a finite series, meaning I'm adding together a specific number of terms. But if I have my summation notation and I have an infinity on the top, this is something called an infinite series, okay? And that would mean that we would have to add up every single term in the entire sequence to get the answer, all right? Okay, so let's take a look at two examples that talk about practicing this notation. So, example number 4. All right, I have the summation from k equals 1 to k equals 4, and the formula is given right here, k squared times k minus 3. So what I'm going to do is I'm going to plug in 1 for k, I'm going to plug in 2 for k, I'm going to plug in 3 for k, I'm going to plug in 4 for k, and then I'm going to add up all the terms. So if I plug in 1, I get 1 squared times 1 minus 3. If I plug in 2, I get 2 squared times 2 minus 3. If I plug in 3, I get 3 squared times 3 minus 3. And if I plug in 4, I get 4 squared times 4 minus 3. Now, why did I write these spaced out so much? Because I want to make sure that I know summation means I add my answers together. Okay? So this summation notation is this plus, plus, and plus. Okay? So let's just take each term by itself and calculate that out. So 1 times negative 2 plus 4 times negative 1 plus 9 times 0 plus 16 times 1. All right, negative 2 minus 4 plus 0 plus 16 will give me a sum of 10. Okay? So kind of scary looking symbol. I can see how it's intimidating, but what we're really doing is just adding up the terms. Okay, so we're doing what we did in the first video where we find the terms, but then the added layer is that we, add them together. Okay? All right, let's do one more example just so we can feel a little bit more confident about this. Okay, so example 5. I'm going to find where n equals 1. So I'm going to plug in 1 for n, I'm going to plug in 2 for n, I'm going to plug in 3 for n, and I'm going to stop there. And I know I'm going to stop there because the top number is 3. So I don't want to keep going. I don't want to go to 4, 5, 6, 7. Okay? So we're going to plug in 1 and 2 and 3, and then we're going to add up the terms. So this is going to equal 36 times 1/4 to the 1 minus 1. That's plugging in 1. Plus 36 times 1/4 to the 2 minus 1. That's plugging in 2. Plus 36 times 1/4 to the 3 minus 1. That's when I plug in 3. All right, let's simplify. So 36 times 1/4 to the 0 plus 36 times 1/4 to the 1 plus 36 times 1/4 squared. Okay. And this will give me 36 times 1 plus 36 times 1/4 plus 36 times 1/16. And let's clean this up and see what we get. 36 plus 36 divided by 4 is 9 plus 36 over 16, and I bet we can reduce that. If I divide this by 2, I get 18, and I get 8, and I can divide by 2 again, so 9/4. So 36 plus 9 is going to give me 45 plus 9/4. And so I can convert this to a fraction with a common denominator of 4. And so that will give me 180 over 4 plus 9 over 4, which gives me 189 over 4. And so that would be my final answer. Okay? Now, before we finish this, I just want to show you a slightly different way of approaching it. And this might be something that you see, patterns that you already see for yourself. But one thing that is good to know is that when I have a constant, like this 36, and I'm multiplying it by everything, I can actually factor that out at the beginning. And it kind of makes my numbers a little bit smaller and sometimes a little bit easier. So what I mean by that is I could have started by saying this is going to be equal to 36 times the summation from n equals 1 to 3 of just the 1/4 to the n minus 1 part. And what that would do for me is keep the numbers a little bit smaller, because now I just plug in 1, 2, and 3. So I get 1/4 to the 0 plus 1/4 to the 1 plus 1/4 squared, which gives me 36 times 1 plus 1/4 plus 1/16. Okay? And then I can go ahead and find a common denominator. So 16 plus 4 plus 1 equals 36 times 16 plus 4 is 20, plus 1 is 21 over 16. And if I reduce here, let's see, 36 divided by 4 is 9. 16 divided by 4 is 4. And so I can get the same answer I got before, 189 over 4, but just with a slightly different process in the calculation. Okay, so really the biggest difference is just that I factored out that 36, and it just kept my numbers a little bit smaller in the inside. All right. So an optional thing, but when you get to Calc 2, you'll see a lot more of this kind of work, but it's okay if we're still on the left-hand side for right now, because we're still in pre-calc, okay? All right, so folks, that's 9.1, and when we come back for 9.2 and 9.3, we'll take a deeper look at some special kinds of sequences and series. All right, see you there.